Okay, we're live. Good. All right. So welcome to Math with Doug. It is Geometry with Doug. We are starting a new unit. The unit is Geometry. Because it's the beginning of a unit, we're going to be doing a lot of pretty basic stuff, and we're not going to want to go really fast. The students can be beginners to this topic, and we don't want to leave anyone behind. Geometry is fun. A lot of students really like geometry because it often involves drawing, and drawing is fun. And even if you like drawing in a more creative, artistic way, anything you learn about how to draw in geometry is going to come in handy. There is definitely an overlap between geometry and art. And that's one of the things I like about geometry. Okay, so I am going to start with the bisector. What is a bisector? A bisector will bisect a line or a line segment. We have line AB here. We also have line segment AB if we imagine that the line doesn't keep on going on in both directions forever. I'm going to bisect line segment AB. Well, to bisect it, what can I do? I'm cutting it in half. That's what bisect means. So to cut it in half, how will I do that? I have to find the midpoint. I have to find a point that's exactly halfway between A and B, and that's where I have to cut the line. What am I going to cut it with? Should I just put a point there, or should I draw a line through? I'm going to draw a line. So my line that I'm drawing is going to be a bisector of AB. It is going to cut AB exactly in half. How do I do that? Well, there's more than one way, and I'm going to do several lines, and we're going to try different ways. But a really easy way is to use your ruler. Unfortunately, we're allowed to use rulers in this lesson. We will use rulers. We will use compasses quite a bit. And we have our protractors. But this lesson does not require the students to use protractors. I still have it because we are going to deal with some angles. And when you're dealing with angles, sometimes you want to measure them, and the protractor is what's used to measure them. So I might measure a couple of angles with my protractor. But I'm not teaching drawing techniques where we need the protractor to do the drawing. We're just going to stick with things where you use a ruler or a compass or both. So here I have my ruler. Well, a ruler is very useful, of course, because if we want to find the point that's halfway between A and B, well, one way we can do that is we can measure the distance between A and B. I'm going to use the inches side of this ruler, and it is exactly 20 inches from A to B. So keeping the ruler there, I'm going to mark the midpoint. The midpoint, half of 20 is 10, so here at the 10-inch mark on my ruler, I'm making a little mark so I remember where it is. Well, this point, which I can call point P, is halfway between A and B. So if I want to draw a line that is a bisector of AB, well, I can draw a line, but I have to make sure that it goes through that point. And at what angle do I draw that line? It's a bisector. That's all we're doing. We're not doing the perpendicular bisector yet, so I don't have to make sure my new line is perpendicular to AB. I can draw the line at any angle I want, pretty much, almost any angle I want. So for instance, if I draw this and call it CD, making sure it goes through point P, I have just drawn a line CD, which is a bisector of line AB, or of line segment AB. Okay, so that, and I just chose that angle just because I felt like doing that angle. If I had used an angle that was way over here like this, it would, so long as it went through point B, it would still be a bisector. So, what's another way of doing this? Well, another way of doing it is to jump ahead to my very next topic. I'm looking at the time here. Because my very next topic is the perpendicular bisector. And I will add in the word perpendicular right here, but I'll write it a little smaller so that it'll fit. Perpendicular bisector. So let's do a perpendicular bisector. I'm going to do it to this one. And first I will name this. I'm going to make this look like a line segment by putting points right at the two ends of the line that I drew. I don't know how long this is yet. And I'll call this one AB again. Now, what if I wanted to draw the perpendicular bisector, but I don't want to have to use my ruler to find the exact midpoint between A and B? Well, this is where the compass comes in pretty handy. This, of course, is a compass. And it's a big chalkboard compass. It's a little clunky, and I play around with this little thing that tightens it, because if it's too loose, you lose the distance between these 2 points and it becomes messy and it makes it harder to do some of our drawing techniques. So tighten this and make sure that it's kind of resistant to being changed in the size. Now, how do I draw a perpendicular bisector? What I do is I go up to either of the vertices. It doesn't matter if I start with A or with B, and I'm going to draw an arc. But I want to choose how far the arc is from A with a bit of care. If I draw the arc too close to the vertex, it's not really going to help me draw the perpendicular bisector. What I want to do is actually I want to go more than halfway. And I can judge halfway between A and B with my eye. So I can see that this, for instance, tighten it a little bit. I can see that this looks, oh, I want it a little bigger. This is going to be more than halfway. So being careful and putting this, this rubber thing, it's a rubber thing when you're doing it on a chalkboard, on point A, and I'm just drawing an arc. And I'm being careful to not pinch the compass so that I change the size. And then I do the same thing, but I put the rubber thing on B instead. And I draw an arc. Oh, getting a little slippery, so I'll be more careful there. Now I draw an arc, and I want it to go all the way above and below the line, because to see the way the two arcs I'm drawing are crossing twice, I want that. Because these 2 points where the arcs crossed each other are very useful right now. I haven't named those points. What I'm going to do is I am going to draw a line through both of those points. So I have to be careful. It is a little clunky using these big tools, the geometry tools on the chalkboard. So trying to draw it quite well. I'm drawing my line through both of those points of intersection of the two arcs I drew. And what I have done is I have just drawn a perpendicular bisector. This line, and I'll use a little square to show it, this line that I just drew, which again I will call CD, is going to be perpendicular to line AB, because by keeping the size of the compass the same when I drew those two arcs, I made sure that these two lines would set me up to be able to draw a line through them. These two arcs set me up to draw a line through their points of intersection, and that line will be perpendicular. And will it also be a bisector? Well, let's prove it by measuring. Now we're going to get out a ruler. We didn't use the ruler to draw the perpendicular bisector, or at least to choose the point where it gets drawn through, but we're going to use it to make sure that, and I'm going to, again, label this point as point P. We're going to make sure that AP is equal to BP. So I'm going to measure it. AP is, I would say, about 9¼ inches in length. And then BP or PB, whichever one I want to call it, yes, it is also 9¼ inches in length. It works. I didn't even know how long segment AB was, but now I realize, well, it's 2 times 9¼ so that means it's 19 inches long. And I can measure that and make sure as well. 19 inches? Yes. So, I drew a perpendicular bisector, which is another way of drawing a bisector. I said I was going to show more than one way of drawing a bisector. Well, drawing the perpendicular bisector, which is a little bit more fussy, is another method of drawing a bisector. But if I ask a student, here's line AB, draw a bisector, and the student chooses to draw a perpendicular bisector, well, that's fine, because the perpendicular bisector is a bisector. The student has succeeded in the task. So we can draw at this angle, we can draw at an angle like this if we want. Let's do another one down here, and we'll deliberately choose a different looking angle. It won't be a perpendicular bisector, it'll be back to being just any old bisector. How am I going to do that? I'm going to measure this, and this one, well, I'll put points A and B on it, and I'm putting them right at the end points, right at the end of the line I drew, so that this is a line segment AB. And I measure this and I see, oh, that looks like it's about 22 inches. So if I want to draw a bisector, half of 22 is 11. I find 11 inches, I make a little mark. And then let's say I decide to put a line that's actually quite close to line AB. Call that line CD. I have drawn a bisector. Line segment AB has been bisected by lines CD. And the point that the line went through has to be midway between A and B. And of course, I can measure that if I want, but I kind of already did it. It's 11 inches, and this is also going to be 11 inches. It works. So bisectors are easy to draw, and really all you need is a ruler, because the ruler helps you find the midpoint, but then the ruler also gives you a straight edge to draw a line through that midpoint, and you have bisected your original line. Perpendicular bisector, there's more rules involved. It can't just be any line going through that midpoint. It has to be a line that's perpendicular, that forms a 90-degree angle with the original line. And it does. And I can prove it. And I said that we don't have to use our protractors much. We're not using our protractors to draw anything in this lesson, but we can use a protractor just to measure things to make sure they turned out the way we thought they would. And that 90-degree angle, I can use my protractor to make sure it is a 90-degree angle. And what I can see is, oh yeah, I get my baseline of my protractor on line segment AB. I make sure that the midpoint on the protractor is right on my midpoint P. And then I look up here and I say, oh, there's 90 right there. So I drew a 90-degree angle when I drew that perpendicular bisector. So that worked. How am I doing for time? I'm going okay for time. And I like asking those what if questions. What if I did this differently? What if I did that differently? That's really what I did here. I did one that I knew was correct, then I did another one. I just tried to draw the line a little differently just to make sure the technique works, and it does. And then I draw a perpendicular bisector. That's a little different, but it works. I've drawn 3 bisectors. Okay, so let's continue with the perpendicular bisector. We'll do at least one more of those, because this is so pretty, I want to do it again. But what if? What's the what if I can do? I just feel so confident that this technique works. Let's see. I'll leave this one here. I'll erase the original one and this one to make some room. I'll keep the label perpendicular bisector there because it is still pertinent to what we are doing. Let me see, what can I do differently? I can make my original line not be flat, not be kind of horizontal with the camera. I can do something fun with it, so I'll make it, I'm not going to try and make it perfectly vertical. I'll make it be a little bit close to vertical. And how long should I make it? And make it longer. How should I do that? This only will draw lines 2 feet long, but I have this handy dandy meter stick here, which is a meter stick on one side and has a yardstick on the other. So this goes to 39 inches, a little more. I'm going to draw a line that's longer than 2 feet, just because I can if I use this tool. There it is. Okay, starting at the 0. I'm going to go all the way up to 34. Okay, now, if I were trying to draw a bisector, and it didn't have to be perpendicular, I might be wanting to stop right now and saying, what's 34 divided by 2? Let's make a mark. But I don't have to, because perpendicular bisector doesn't require me to divide the length of this line by 2 in 2. So I'm going to try to remember how long it is. I'll write it here, 34 inches, because that's useful information. Okay, and I'll label it AB. Make sure this shows on the camera okay, and it does. Okay, so I want a perpendicular bisector. How do I do that? Okay, here's the results of the what if. You start thinking, oh wait, that's really long. Is my compass going to stretch long enough to do this? You could draw a line on a piece of paper that would be too long for your compass from your geometry set to be able to open wide enough to do the arcs that you need. But I think this one will be up to the task. And I actually have 3 compasses here, so I will show you them. Okay, so this one, my favorite one is the wooden one that I was already using. This one's actually made of plastic, kind of looks like wood, but it's plastic. And they're both quite good. They both keep the distance between the 2 points quite well. They both have the rubber tip. They both hold chalk kind of helpful when you're doing this on a chalkboard. And I also have this thing, which isn't the same type of compass. So this is a compass that's really good for drawing circles of all different sizes, and I will use that because I'm going to draw some circles later. It's kind of a cool tool, and see how even the chalk fits in there. Now, back to my wooden protractor. Remember, the strategy was to draw an arc from A and draw the same sized arc from B, but you don't want to draw the arc too close to the vertex you're drawing it from. You want to go more than halfway, because going more than halfway, well, why did we do this? This worked out so well because we went more than halfway, because going more than halfway meant that the two arcs we drew would cross each other in two places. So I want to go more than halfway. So here's another what if. This time I went just a little bit more than halfway. See if I can go way more than halfway. I don't know if I can. See how much this will stretch out. But when I look at this, I can see, yeah, that is quite a lot more than halfway. I'll do a little more. Oh, I don't want to break it. Okay, so from A, I'm going to draw an arc. Now I have to be careful, because if I draw the arc too small, the two arcs won't cross each other. So I'm really stretching my tools to the limit with this giant geometry drawing on my chalkboard wall. I'm going to have to draw quite a long arc. So I'll draw that, and it has to go all the way to the other side of the original line. And it's hard to do. This is hard to do. I'm going to have to continue it like this. Pretty good though. Because like I said, I want the arcs to cross each other. So I'm really pushing the limits with this thing. Now do the same thing from B. Okay. And to make sure the arcs cross, well, now it's easier because I can see where the first arc is. So if I start my arc here, it's not going to work. I have to start it down here so that it will cross the first arc. So I have to be careful. I managed to do that. Hold still there. Yeah, I'm having trouble because the chalk isn't long enough. Pull the chalk out a little more. There. Tighten this little thing that holds the chalk in place. It's an interesting little piece of equipment. And try again. Okay, that first bit's drawn quite well. Can I keep going? Will the chalk run out? It's a good thing I have more than one compass. Okay, so this was quite a stretch, and really stretch in all senses of the word. I'm going to put this thing down. What was the next step? The next step was to draw a line from this point of intersection where the two arcs crossed each other, which is hard to see because it went right in the middle of these words, and make sure that line also crosses this other point of intersection, which is way easier to see. So I'll start by darkening this so we can see it better on the camera, and darkening this. So this is the point of intersection that I'm talking about. Will this be long enough? That's another thing where I'm stretching things to the limit. Okay, and I really did almost get to the limit because this is the longest straight edge I have. So, oh, I'm not stretching my arms to the limit as well. Oh, did it though. Whew, I did it. I did the same technique with a few crazy what ifs, and I managed. This is like a student trying to do a drawing of a perpendicular bisector on a piece of paper and use up as much of the paper as they can, and they might find that the tools they get in a typical geometry set might not stretch to the extent that these ones did, but I managed to do it. I made it. So I'm going to label this point P. I know that this line that I drew is perpendicular because the technique will always produce a perpendicular bisector, so long as you can keep that distance between the 2 points of the compass equal. So I'm going to draw the little square thing that shows that there's a 90-degree angle, and of course there are 4 of them. I could draw little squares in any of these 4 sections of the drawing. I just chose to draw it on that one. So my original line was line segment AB. I'm going to call this line CD. My midpoint is P. I have my perpendicular bisector. I have succeeded. So that was fun. It is fun. All of these geometry drawings are fun. What's next on my list, and how am I doing for time? because that took a while. I feel like really got a good stretch. I'm always saying, and remember to, in the middle of your math lesson, stop and stretch, take a sip of water, do a stretch. I don't know if I have to do any extra stretching because these drawings were really making me stretch. Okay, perpendicular bisector is a line, right, or segment that divides a line into two congruent segments at a right angle. Well, the right angle we just talked about, but the two congruent segments, we didn't really test that, but we should. So from D to P, using the inches side of my ruler, is just a little short of 19 inches. From P to A, just a little bit short of 19 inches. It worked. Now, if you're a little off with geometry drawings, that's what's called drawing error. And you can try to eliminate the error as much as possible, but when you're drawing something, it can be impossible to do the drawing perfectly. So usually when we're looking at a student's drawings and evaluating them, we have a permitted amount of error, permitted amount of degrees in an angle, or inches or centimeters or millimeters in a drawing. And with a chalkboard, it is quite tricky because even the line of that chalk draws is so thick. So if you want your drawings to turn out really well when you're doing them with regular geometry tools on a piece of paper, there are some things that you can do. And one of those things is get a really nice sharp pencil, or even a stack of nice sharp pencils handy. And when you draw your lines and your arcs, if you're using a nice sharp pencil, the lines and arcs are slimmer, and then you can be a little bit more fussy about the way things are placed, and hopefully you're pleased with the results. Okay, what's next on my list after the perpendicular bisector? Constructing a parallel line. So of course we know what parallel lines are. I know the students know. Two lines are parallel if they never cross. So I like to think of train tracks. The two metal bars that make up the train tracks. Well, we don't want them to cross. That would not be good for the train. So they are the exact same distance apart, and you could go with a meter stick and you could measure those. In fact, I have train tracks right here, but they're from a little model train, and I could check for that. Are the two bars the same distance apart if I go to different parts? Well, they better be, or else the model train will not stay on the tracks. Okay, so train tracks are a good real-life situation that makes us think of what parallel lines are. I'm going to do some erasing. And although I have been getting my stretching from all these drawings, I do need some fizzy water, so I think I'm going to disappear for a few seconds while I run and get a can of fizzy water. I can now erase this label, the perpendicular bisector label. And I'll erase everything except my topic label. And I'll be right back with a can of water. Pardon me for that. This is calamansi, citrus, and strawberry. Pretty fancy. Okay, now we can move on to constructing parallel lines. Okay, how do we do an exercise where we construct a parallel line? Well, we have to start with a line, so that we can make another line that's parallel to the first line. So I'm going to start by drawing a line. And I'm going to make it 2 feet long. I'm going to 2 feet long actually on the chalkboard wall. I'm going to use 2 foot long lines a lot because that's how long this ruler is. And I'll call this line AB. Now, if I'm going to draw another line that's parallel to this, well, I could draw it up here or down there. And it could be done either way using the same technique, but I'm going to draw it up here. So I want to have a point where that I'll make sure my second line, my line that's parallel to AB, will go through. So I can sort of randomly choose that point. Let me think here. Where do I want to put it? I don't want it to be too close because I don't want the drawing to be too cluttered. So I'm going to put a point here, and I'll call it C. So I'm going to draw a line CD which is going to be parallel to line AB. How do I do that using just ruler and a compass? Well, the first thing I'm going to do is I'm going to draw an arc. I'm not so sure if this compass is going to make it all the way through the lesson because of this chalk issue, but fortunately I do have that other one. There. I don't want the arc to be that wide. I want the arc to not be too close to line AB, it would be cluttered. I also don't want to make the arc draw too close to point C because that would also create clutter. So I'm going to choose a distance to put the arc from A that's sort of in between. It doesn't have to be exactly halfway in between. I think I'm going to do it, say, like this. So I'm just going to draw an arc. I'm drawing it right through line AB and making it longer than I probably need. And then what do I do next? What I do next is I draw the same arc, but from C. So same arc means I am not pinching this closer together or letting it get further apart. I'm being careful. And I'm getting the rubber point, or if you're using a typical geometry set compass, the pointy metal point, on C, and then I'm drawing an arc just like I did before from A. So, and I draw it longer than I think I'll need. Maybe draw it a little darker so that it can be seen better on the video. I'm starting to worry about this. See, I usually press pretty hard with my chalk when I'm drawing on the chalkboard wall while I'm making a video like this, but it's not so easy to press hard when you're using this thing. So this will have to do. I'll try to press a little harder when I draw the next arc. What is the next step in this process? I want to use a compass to measure. Oh, this is why I was getting a little flustered there because I was forgetting something. I want to draw a line from A through C. And again, I'll draw the line longer than I think I need. I'm going to make sure it goes through this arc, but I don't think it even has to. There. So I draw a line through A and C. Now I'm ready to do what I need to do. I need to measure. And I'm actually measuring with a compass. And what I'm measuring is this arc between where my original arc crossed this line AC and where that original arc crossed line AB. So I'm using the compass to do that. Now it looks like it's already open to the exact right amount, but if that happened, it would be a coincidence. So actually, this is a little too big. I'm going to have to pinch this closed a little bit. If this isn't getting in the way. So I pinch this closed a little bit, and I check, and I say, yes, that's good. So, what do I do now? I'm going to take my rubber thing and I'm going to put it on C, and keeping this arc distance, keeping it the same, I'm going from C, I'm going to draw an arc that goes through, what a mess. Look here. Yeah, that's what I did wrong. I was putting my little rubber thing on C. I don't want it on C, so I'm going to erase that little arc I just started drawing. We'll pretend it never happened. Okay, so I measured this distance. What I want to do is I want to do the rubber thing on this place where my second arc crossed line AC, and I'm going to draw an arc that crosses here. Okay, that makes sense. The other way wasn't making sense. I knew I was doing something wrong. It's a good thing I have notes to remind me of the steps of doing this. Now, what did I just accomplish? By drawing that third arc, I only have 3 arcs involved in this drawing, but it's the last one. By drawing that third arc, the point where these 2 arcs cross, the point where the second and third arcs cross, has to be on the same line as C if that line is parallel to line AB. So let's see how this looks. I'm going to draw a line through C and through this point where the lines crossed, or the arcs crossed. And what I have just done is drawn a line that is parallel to line AB. I'm going to put a D. I'm going to look at it. From here it looks crooked. It looks like these are train tracks that would gradually get closer together, which we would not want. But over here, okay, and then over here, it looks the same. perspective, there's all sorts of interesting perspective happening. I think I did a pretty good job. I think a student who does the same technique on paper might end up with parallel lines that are slightly more perfect than mine, but considering I'm doing it on a chalkboard wall, I'm actually quite pleased with this. Let me get over to where you are and look at it. Oh yeah, from the camera's point of view, that's where I am now, I'm right beside you. From the camera's point of view, those two lines look really nicely parallel to me. From over here, well, they look like they're squishing together this way. And from over here, they look like they're squishing together that way. This is only happening because I'm using a chalkboard. And there's a camera there, and I'm trying not to be in between them and get in the way. So when you're doing this on paper, it's not going to be, you're not going to be standing off to the side of your paper looking at it at a weird angle. You're going to be looking at it from above, and you'll be able to judge how well you did with the parallel lines. And there's other ways of judging too. There are tricks we can do. So what common objects do we have that we know include parallel lines? Well, for instance, a piece of paper. Most pieces of paper are produced in a way that this edge is parallel to that edge. And if I put this here, oh, it's looking pretty good. Looking pretty good. This piece of paper is right on line AB, this edge of the piece of paper, and the opposite edge, which has to be parallel, is just below line CD. It's actually convenient. If I had tried to do it this way, I wouldn't be able to see what I was doing. But this one worked out quite well. Useful. Interesting how ordinary objects can be useful tools. Okay, so I am able to construct a line that is parallel to an original line. I have to choose a point. Notice how I sort of randomly chose point C. So it doesn't have to be above point A and to the right. It doesn't have to be at exactly this angle. You have a lot of flexibility, but the technique works, and that's the important thing. How am I doing for time now? Let me see. I want to have enough time for each of the types of drawing, but if I do have enough time, I'd like to do another one of these. There's only doing one example. It's not enough. But some things take so long that you only have time for one example. So we have, I think I have time. Oh yeah, I have time to do this again if I'm quick, so I'm going to try to be quick. So, quickly, erase, whole thing, draw another one. That's shorter than 2 feet long, but I don't care because the length of the lines that I'm doing right now hasn't really mattered very much. I'll call this AB again. It's not perfectly horizontal, but it doesn't matter. So long as the other line is parallel to it, that's what matters. In fact, I'm going to do that on purpose. I'm going to make the line not horizontal on purpose so that I can test my technique. I'm doing another what if. So there's A, and there's B, so we have line AB. I want another point somewhere, and I'm not putting it down there because I won't draw well if I try and reach down there. So I'm going to put a point, say, I'm putting it here. So from line AB's perspective, this one stayed a little more above A, but I don't want it straight above A. Okay, and I will call that C. Now what do? I have to draw some arcs. I'm choosing an arc that is somewhere in between A and C, not too close to C, not too close to A. So I'm just randomly choosing a distance for this that I like, and I'm going to draw an arc. I'm going right down through line AB, and then from C, not changing the size of the arc I'm drawing, I'm doing it again. Okay, I'll double check that this hasn't changed in size. It looks good. Okay, now I have to draw a line between A and C. Straight edge. This is going to make my labels messy. I'll just stop there. It's fine. Okay, now what do? I get my compass again. Kind of back and forth between the ruler and the compass with some of these techniques. And what I'm doing is I'm measuring this. And again, see, this is a good example because you can see this is not exactly the same distance. I have to make this bigger to make it measure with my compass. And then I have to think I made, yeah, I have to make this line longer. Okay, so it is getting messy with the labels. I'm making this line longer because I need it to go through this arc. Want it to go through that arc. Okay, so I measured that. Now what I want to do is go here, where the arc from C crosses this line on AC, and I am going to draw another arc. And the point, if I draw a line between point C and this point where the second and third arcs cross, it should work. I should have parallel lines. I'm feeling confident, so I'm not looking at it and trying to judge, oh, did I do it right? I'm just going to go ahead and draw this line, and then I'm going to see if they look parallel. Now again, from here it looks all wrong. And from over here, it might not look that good, but if I go over to where you are, and look at, CD, line CD is looking quite parallel to line AB if we stand over here next, where all the smart people are standing. Yes, I did it. That didn't take long either. I'm glad I did a second example. I like this technique. But I have to move on to the next type of drawing. Oh, bisecting an angle. So we're bisecting again, but it's not a bisector of a line or a line segment. It's a bisector of an angle. This is a fun one. Okay, so first I need an angle. I'm going to draw an angle with my ruler. Any old angle will do. Okay. I will call this vertex B, and I will put a point A and a point C. So we have angle ABC. We could also just call it angle B. That, in this drawing, it's clear what it means. Angle B, well, that must be angle B, because we don't have a drawing full of all sorts of angles. I like this way of labeling angles better, where you use the three letters and you know the vertex is the middle letter. I like it way better because sometimes in geometry you have multiple angles on the same page and it becomes confusing. And sometimes B could be a vertex for an angle over here, but it could also be a vertex for several other angles at the same time. So when they say angle B, you say, which angle B? But in this case, we know, oh, it's this angle B because it's the one that starts with A, goes through B, and then goes to C. It's more clear when you use the three letters, so I like that better. Okay, so now we are going to bisect this. And how do we bisect an angle? Surprise, surprise, we use the compass. We'll see if this chalk will last through the whole lesson. Okay, now how am I going to do this? How do you bisect an angle? So we choose an arc, and again, we sort of get to choose an arc size that we like. Because of the size of this, I'm stretching this out a little bit. I don't want to draw an arc that's too close to A or C or too close to B. It'll be cluttered. A little smaller. Okay, and what I'm doing is with my pointy thing, if it's a regular compass, and rubber thing, if it's a chalkboard compass, on B, I'm drawing an arc here, but I also want to draw an arc here of the same size. So I don't let this change in between. Then, what do I do next? Well, we can see the points of intersection between the two arcs we drew and segment BA and segment BC. So we get our rubber thing, or our pointy thing, and we put it on that point of intersection, and then we draw an arc, and we just sort of make the arc longer than we need because we're not exactly sure where we need it. And then we do the same thing here. And we draw an arc, and we make sure these two arcs cross. This is actually so easy. It's fun because it's easy. Because where these two arcs crossed, where my third and fourth arcs from this drawing cross, if I draw a line between vertex B and that point of intersection, I have bisected the angle. So, let's give ourselves some labeling. Let's call this D. That means I just created two more angles. We already had angle ABC. Now I've created angle ABD and angle DBC. Angle ADB and angle DBC. Okay, 3 angles. I wanted to write them down because it's starting to be too many angles. I'll forget what I'm talking about. But what matters here? It was a bisector. What matters is that this angle should have the same measure as that angle. And of course we measure angles with degrees, and we usually do that with the protractor. So although we did not use a protractor to draw any of this, we're going to use the protractor to measure the 2 angles and see if we're satisfied that they are actually equal in length. Because if I really bisected, then these 2 angles should be equal, not in length, equal in degree measure. So we have to know how to use the protractor. We get the baseline of the protractor going on one of the lines that makes up our angle. So I'm doing the top angle first. I'm doing angle ADB first. So I'm putting the baseline of the protractor on line segment BD. I make sure that the 0 point of the protractor is right on the vertex. And then I measure my angle. And of course, with the protractor, you have the 2 sets of numbers. We're on the right side of the protractor, so we're using the inside set of numbers. And I'm estimating this angle's measure as being about 26 or 27 degrees. So I'll write that. I'll call it 27 degrees. And now I'm doing the same thing with angle DBC. So baseline, 0 point, and then I'm using the inner numbers again. And now this time I would judge it 27 or 28 degrees, so I think I'm close enough. With the error that's allowed when it's a drawing, even if someone else measured and said, hey, I think that's 26 and that's 27. Well, they're so close. The difference is not because I didn't bisect the angle. The difference is in the use of the tools, especially the clunky tools that you have to use when you're on a chalkboard. So if you want your bisected angles to be even more perfect, well, like I said, use a nice sharp pencil and be careful and take your time, and don't do just one piece of paper sliding around on a tabletop. That's another thing that happens when you try to use these tools. You can use a stack of paper. You can make sure that the paper's not sliding around, and it makes it easier to do a better drawing. And that's all part of the fun of geometry, is being fussy and trying to produce better drawings. So I have bisected an angle. Let's see, how much time do I have? I have time to do another one. I'm going to do another one. What if? What type of what if can I do? Well, I keep on drawing angles that are opening that way. I can draw one that opens the other way. I can draw an angle that opens downwards and try the technique that. I like that. I'm going to do that one. I'll try drawing an angle that opens downwards, and then I'll bisect it. I could make the angle bigger than angle ABC was, or I can make it narrower than ABC was. So let's do it. Let's draw an angle that we feel like bisecting, that feels a little different, because if the angle feels different, that doesn't matter. If the technique works, the technique will still work. So I'm going to do an angle that opens downwards. I'll make it a little wider. Yeah, a little wider. A little bigger. And I'll call this, just for fun, D, E, F. Angle D, E, F. Draw that a little bigger, try and make it look nice. Okay, so there's my angle D, E, F. It's a little bigger and it's opening downwards, but otherwise it's an angle just like other angles, just like angle ABC, not too different. What do? I get my compass, and I am going to switch to this other compass because this piece of chalk looks like it's long enough, and I'm going to draw an arc from my vertex E so that it goes through line segment EF, and then I'm also going to draw an arc that goes through line segment ED or DE. Make sure that the arcs are the same, that I didn't pinch this closed or pull it open anymore, they are the same size. And then what do I do next? What was the next step again? We get the pointy thing and put it on this point of intersection between our first arc and segment EF, and we draw an arc, and we make sure it's bigger than we think we need, because we don't want to have to go back and redraw it later. And then we do the same thing over here, draw the arc, we make sure it crosses the other arc. We now have 4 arcs. And then we get a straight edge, and a piece of chalk which is too short, we make that longer, and we draw, this is about as long as this straight edge would have gone. We draw from vertex E through the point of intersection of our 3rd and 4th arcs. We have bisected the angle. And if we want, we can call this G. And we have names for all of the angles, but I'm not going to list the names or write down the measurements. I'm just going to measure them. And again, just for fun, a different protractor. Not very different from the first one, but the first one was wooden, and this one is plastic. These were 2 different sets of chalkboard geometry tools. Okay, I want to measure these angles. So, baseline of protractor on segment DE, 0 dot of protractor on vertex E, and I measured to here, and I'm seeing, using the inner numbers, which are upside down right now, but I can still read them, I'm seeing about 36 degrees. And then I do the same thing with this angle. I'm going to do it this way, baseline, 0 dot, 36 degrees, well, very close. I was looking like 35, very close. I have bisected the angle, the technique works, and the technique is fun. Oh boy, I'm doing a lot of talking. Okay, what's next on my list? Copy an angle. Copy an angle. Well, I need a first angle to start with, and I'm not going to use this one because there's too much clutter of arcs and labeling, etc. So I'm going to draw a new angle. Let's see. Need chalk, need straight edge. There, draw that line. And then draw another line. I'm going to call this one PQR. Just for fun, use some different letters from the alphabet. So this is angle PQR, and I want to copy it. How do I copy it? I have to look at my instructions for this, because it's a bit of a longer set of instructions. But like all of them, it becomes easy once you practice it. Okay, so I have to draw a baseline for the second angle. Now you might think, since I'm trying to make a copy of this one, that when I draw a baseline, I'm going to draw a baseline kind of like this. When I draw the baseline over here, then I'm trying to make sure that it's pointing in the same direction as this one. But the truth is, with the copy and angle technique, you don't need to do that. So I'm going to not do that. I'm going to draw a baseline for another angle. I'm going to just do it like that. I don't have to make it the same length. I don't have to make it point in the same direction. I need to draw an arc. Where's the compass that I'm now using? It's this one. Still have this in my hand. Too many tools in your hands at once doesn't help. I'm going to draw an arc all the way through this. I don't want to do it right where the P and the R are, so I'll squish this down a little bit. Draw an arc all the way through this. Aha. Next, on the copy angle, which is going to have this line in it, from this baseline, and I could choose either end, I'm going to draw the same arc, which means I'm not changing this measurement. I'm not squishing it in or pulling it apart. I'm going to draw the same arc. And again, I draw it longer than I think I'm going to need it. Because if you draw your arc too small, then later on you look for points of intersection, realize, no, I didn't draw it long enough, I can't see the point of intersection, you have to go back and try and redraw it. It's just easier to draw them bigger than you think you'll need them, and then usually they end up being big enough. Now I'm going to measure this first arc over here with my compass. I like using a compass to measure things. It's neat because we're so used to grabbing rulers. It's nice to realize that we can use other tools to do things like that. And I'm glad that this is not exactly the same length that this was already set at, because I don't want the students to think it has to be. It doesn't have to be. It depends on how far I drew this arc, really. It depends on how far apart these lines are. I want to measure this, so I'm getting the rubber thing on one of those points of intersection, and then I'm squishing it down a little bit until I'm satisfied that I have just measured this arc. A little bit more there. Okay, now I want to preserve this. I do not want to squish this. Okay. Go to where this arc intersected this baseline of my second angle and draw another arc. And make sure it crosses this one that I did before. Well, the intersection, the point of intersection between these two arcs, that's what I need. It's hard for me to see, again, especially when I'm way over close like this, but I'm getting a good feeling that if I draw lines from here, the vertex I was using, through that point of intersection, I'm going to have successfully copied this angle. There. Okay, so I'm going to name this just for fun, and I'll name it angle FU, not there, N. So it's angle fun. Okay, so we're going to see, just for fun, I wanted to call it angle fun. We're going to see if angle fun is equal in measure to angle PQR. To do that, I guess I'm going to use my protractor. So back to this thing. Okay, angle PQR, I never actually measured it, did I? I just drew it. So I don't even know what the measurement of it is, but using my protractor, I am seeing, I like the idea of saying that this is 47 or 48 degrees. So if this one's really close to that, I know that it worked. It means that I copied the angle. Set this up. Oh yes, oh yes. I call that 48 degrees. I'm quite happy with that. So we're not really using this tool for drawing this week, but we are using it for checking our drawings, and it's coming in handy. The protractor is handy. Okay, so I know how to copy an angle. How much time do I have left? Not all that much time. I only have a couple of other things I wanted to talk about after copying an angle, but I did want to do a second example, so I'm going to. What if I tried to make the copy completely point the other way than the original? Let's try that. That's a what if. Okay, I need to draw an original angle. I'll draw it over here. I'll make it a little skinnier, let's say. Skinnier, I don't know if the word skinnier is really good terminology to use in geometry, but I'm just going to go with it. Okay, so there's a fairly skinny angle. An angle of a fairly small degree measure, he says again, using better terminology. And let's call this angle JAZ. Okay, now I need a baseline for another angle, but I want to make the other angle open like this. So I'll put a baseline, and again, it doesn't really matter where I put the baseline or exactly how I tilt the ruler. I'm going to draw that, and that's all I need for now. And I'll use this as my vertex, because of course if I use that as my vertex, it would look too much like the previous drawing. I'm using this as my vertex in the second angle. Okay, I'm starting to feel more comfortable with this. My next step is to draw an arc all the way through this. I don't want it too close to the A or too close to the J or the Z. The way it's set right now is pretty good, but I don't want to make you think that it has to keep on being the same. It doesn't. It's time for me to just choose a size of arc I want to draw and draw it all the way through this. And then starting over here, so I'm putting the pointy thing on this vertex, I'm going to draw the same sized arc. And again, make it bigger than I think I need. Okay. What was the next step? I put down the compass, but I'm still using the compass. I'm going to measure this arc with the compass. This is definitely too wide. So I'm going to squish it down so I can measure this arc. Oh, that's pretty good. I did a good job of squishing, so preserving that. From here, is it from here? I want to draw, yes, it's from here for sure. I want to draw the same sized arc so that it crosses the other one. And at this point, I think I might be pretty much finished. It's all finished except for the measuring and being proud and the labeling. So I'm going to draw there. From the vertex I was using through the point of intersection of those two arcs, and I should have an angle that is the same measurement as this one, JAZ. I'm going to call this angle RNB. Okay, now let's measure it, because it's time to move on to my next topic, which is drawing circles and arcs. I haven't drawn any actual circles yet, and I'm almost out of time. So let's measure these quickly. I call that 35 degrees. This one. Remember, when I'm doing the other side of the compass, of the protractor, I end up using the different set of numbers. So I'm on the outer set of numbers, and yes, that's 35. It worked. So that's neat. I really like this technique, because when you're thinking about doing it, when you're first learning to do it, you don't expect it to work in a way that's so flexible. I can draw my second angle pointing any way I want, and it still ends up being a copy of the first one, because they have the same degree measure. I'm happy with this. Okay, so all that's left now, and not very much time to do it in, is to construct some circles. Okay, so I want to talk a little bit about constructing circles. Now, I have compasses. I do woodworking, and here's a piece of wood. Okay, I make bowls. It's one of the things I make. I make other things too, but bowls are one of the things I like making. And bowls are supposed to be round. They're circular. So when you take your block of wood that you want to make a bowl, one of the things that you want to do is you want to find the center. And this tool is a center finder. And I'll try and put it where the students can see it. You can see there are a lot of numbers on it if I don't kick the tripod too much. And lots of circles, and there are all sorts of little holes. And the holes you can put your pencil tip through, or if you're drawing on wood, you can even just use a pointy metal tip and just scratch the wood so that you can see your circle. So what you do to find the center is you put the center finder on top of the piece of wood, and then you just see what's the biggest one of all these circles that are printed on this in white. What's the biggest circle that I can fit completely within the block of wood? And that tells you what's the biggest bowl you can make. So that's cool. And then of course, I could just trace this if I wanted. I could get a pointy metal thing and stab it into the wall, and I could stick my pencil tip through any of these holes and draw all sorts of circles. It's not really the best geometry tool. It's a good woodworking tool. When I'm teaching fractions, I like to use pizzas. So I use this thing a lot to draw circles. Is it the best tool for drawing circles though? I'm going to say no. It's great for drawing pizzas so long as you need pizzas to be this size. You can just put a circular thing and you can trace it. But the problem with that is it's only making a circle of one size. Even that other one with all the little holes, it only makes circles of certain sizes. It doesn't give you complete flexibility in the size of the circle you draw. Then there's this cool one. This is an A+ compass. It's called an A+ compass, where you do get to choose the size you want. That's neat. It has a rubber tip. You get the rubber tip down and you just drag the chalk part. Make sure that you don't move the rubber tip. And that can be tricky sometimes. But this thing rolls quite well. Nice circle. What I should have done though is I should have marked my center first. I always forget to mark the centers of circles, and then it's hard to find them afterwards. So that was a nice big circle, but if I just move this little thing closer here, I could draw a small circle. Pretty cool. It is a compass. It's a type of compass. But these compasses that we're more used to in geometry class, that come with geometry sets, are also very versatile. So what you can do is you can just put a dot anywhere you want, and you can say that's the center of my circle, and I'm going to draw a circle and decide whether you want it to be big or small, and use your compass to draw. And that's technique. You have to practice. You don't want this thing sliding on the page because it will ruin your circle, and it is tricky to get it to go all the way around because your own arm gets in the way, like mine is doing very soon here. But you can learn some techniques. One of the techniques I suggest to my students is don't try to draw with a compass on a piece of paper that's just one piece of paper sliding around on the desk. It slides around and it makes this thing move and it makes your circle all crooked. So one thing is I always like to take a stack of pieces of paper and draw just on the top one. It just seems to make everything more stable. Another thing I do sometimes is I don't move the compass. I hold the compass in the position I want and I just twirl the piece of paper around. I've used that one quite a lot. And then of course drawing arcs. I wanted to talk about drawing circles. I'm running out of time. It's a good thing that the very last thing I wanted to talk about was just drawing arcs, because we've been drawing arcs for the past half hour. If you can draw a circle, well, you just draw an arc that's not as long and you drew an arc. So let's draw an arc the exact same radius, with the same radius, which means I'm not squishing this, I'm not changing it, but I just won't finish. I won't go all the way around to form a circle. Okay, I drew an arc. So I can always draw arcs. Oh, and it picked up some chalk dust from the last one and made a little center dot for me. How nice of it. And if I find the center of a previous circle and draw, I can draw a circle inside a circle, and that looks pretty cool. If it's art class and I'm trying to draw an eye, although, you know, people's eyes aren't perfectly circular, are they? Mocha's eyes are circular. My dog Mocha's, her eyes are completely round. Kind of cute. Okay, so I already have a center dot here, so I'll do another one like that. And at this point, I'm going to stop, because that's enough for this week's lesson. And I stopped. I didn't even draw the whole circle. I just drew an arc. And what does that look like? It looks kind of cool. It's kind of almost setting up to be some kind of logo. All right. So this has been fun. The time flew. I am very surprised I'm already out of time. I'm glad that you were with me for lesson 1 of geometry. I look forward to teaching you lesson 2 next time. Goodbye.